Recording. All right. So what we're going to do for next week is I'm going to do half of, you know what? Since we're going to finish this module this week, um, we're just going to get into this unit next week. For my algebra class, we did something a little different. But since this is at like a more leisurely pace, I won't do it. Never mind. We're just gonna start this on Wednesday then. And if anyone wants to finish this unit next week, like just have it done, we can talk about having like a Friday class or something. If you guys want to get it done with me, we can talk about that um, more on Wednesday, this Wednesday, to see what we want to do since there's only two of you right now. But let's get into solving exponential logarithmic um, functions. All right. So solving exponential and logarithmic functions tutorial. Let's see what our objectives are. Our objectives are, well, that's not saying much, Edmentum. So we're going to solve exponential and logarithmic function. Thanks for the clarity on the objective. At least it's straight into the point. So again, watch the introduction on your own, but we've been doing logarithmic function for a while now, so hopefully um, everyone feels a little comfortable with it now. I like how Admentum took its time with it. Usually I feel like book any type of curriculum speeds through logarithms and everyone forgets logarithms right away. So right now, they give us this exponential function. And if we ever want to solve for the specific year, we're going to have to use logs to solve for the year. If we want to solve for the value, we use the exponential. So going into this, let me turn on my pen real quick. So if we're going from year to, what are we talking about here? To value, year to value, we're going to use, this is going to be an exponential function. But if we want to go from value to year, we're going to have to use the inverse of that, which is a log function. So let's get into this. So looking at this, oh, there's Thomas. Hey, Thomas, did the remind help you get into the class? Okay. I mean, is this working out for you though? Like me sending you the link? Okay, cool. So if I forget, just send me a remind, and then I'll send you the link. So and that goes for anyone. If you guys are having trouble joining the class, either send me an email, or you know what? Don't send me an email, because once I'm in class mode for Algebra 1 and this class, I have a hard time checking those, but I do check my remind and my voice. So send me a text either through remind or through my Google Voice number. All right. So again, so just a quick heads up. So if we're doing year to value, we're using exponents. If we're going from value to year, we're going to use log. So right here, we're going from year to value. So we're going to be using our exponents. Did they give us the equation? I hope they did. Compare the predictions to the actual value. Did they not give us the equation? Dow Jones Industrial. So they're talking about the stock market. So we're talking about how, if we can predict this. So if we're just using the graph, we're going to have to try to figure out what our value is here. So we know that it's some type of exponent. So when we go into this, I figured this, oh, they didn't even go into it. No, I was going to say, I figured out in algebra, I can just submit it and I can explain to you what's going on here, but they're not using it to submit. So what we're going to do here is the rate of change They're talking about the prediction, actual here. Oh, I see what they're doing. We're going to get into that 2012 later. So what they want us to do here is our prediction is going to be following this graph. So they're saying that the stock market goes up exponentially. So what we're going to do is when we go to 2002, we're going to go over here. We're going to guess. I want to guess that's about 12,500. So you're just guessing for this one, essentially. Not guessing, but rounding. And then for 2004, our prediction is going to be 16,000. They're doing this since they're not giving us an actual equation here yet, which is weird that they're not. All we're doing is looking at the graph to solve. Eventually, we will use exponential functions, and then they want us to figure out the actual function. So when we're looking at the actual one, so we're using the graph to predict. When we want to solve for the actual Dow Jones, what we're going to do is going to open up a tab, Dow Jones 2002, and we get these values. So we can actually go into here and they give us a little chart. And here we can get the actual average close. I'm assuming they mean closing price. Let's go with the closing price because usually when you follow the news, what it means by closing price, guys, is the stock market goes up and down as people buy and sell. So again, we're not focused so much on what it is, but the stock market goes up and down. So it'll open is what it started at the beginning of the year, and this is what it closed at the end of the year. So things open and close. Then throughout the year, there's highs, there's lows, and this is the value of all the companies in the Dow Jones. I believe the Dow Jones keeps track of 30 companies. I don't know for certain. Don't quote me on that. But just go off of the closing value. I'm assuming that's what it is. Since these are historical values, these should be more accurate. Let's take a look here. So actual. So if they're doing actual, 8,340. So let's go here. So 2002, 8,000. So it looks like they want the year close. They want the closing year. Okay. So don't do the, oh, that makes sense. They don't want the average. They want the actual closing. Okay. So your numbers are going to be from here. So year close. Make sure you're using the year close values. And just to make sure, 2014, 10, 783. So 2004 is 10783. And it looks like they're just using the numbers themselves. They're rounding these up to the end in 2. Yep. They're just rounding it up to the nearest dollar. So use the year close and the nearest dollar. For this one, all we're going to do is go on the graph and kind of line them up. Is this making sense? So now, why might the predictions made by the equation not match the actual values of the Dow Jones? So here, oh wow, we didn't even do the 2012 one. So what was the point of mentioning 2012? We might do that in a separate activity. Why might they not meet it? Well, even though the government, so the way this works, the way the stock market kind of works is what we value it at. So it goes based off of our buying and selling. Sometimes we don't value companies more. Like we're like they haven't really done much to value it more. There's a lot in finance, guys. But what so for that reason, what I'm gonna say is sometimes the values don't go up as planned, I guess would be the best option. If you guys want to talk more about finance, I can talk to you. There's a lot that goes into it. Inflation, the idea that our money is going to be worth less. So think of it this way. If you're buying something, so let's say I'm buying this house. The house is always going to be worth something, right? It's going to have value. Well, over time, our money goes down. So what ends up happening is the value of this house goes up. It's worth more money because the dollars are less. So that's why usually it goes up and down. So there's a lot of things. There's inflation. There's maybe people don't want to buy that house. There's a lot that goes into it. So that's a very heavy question. Too much to go into for this class. Solving exponential. So now they want us to solve it. This is what I thought we were going to be doing from the beginning. Solve this one-to-one property. So how to change an exponent to a log. So we're basically just finding the inverse. So if we want to get rid of an exponent, we're going to use a log to get rid of the base. We're going to use the log to get rid of the base. If we want to get rid of a log, we're going to, I call this basing. We take the natural log of that to the power property to obtain this. Okay, so they don't even have a word for it. I really wish they had a word for this. I call it basing it. Because I've not seen anyone that describes this idea. They call it the inverse property, but I feel like that applies to anything. I call it basing because it's the idea of taking something and putting the base on it. So I don't know. I really think they need to figure out a word for this besides using inverse property. But for now, if you hear me saying the word basing it, it's just this idea that we're going to get rid of this base by putting the base at the bottom. We're not raising it to a power. That's why I use the term basing. Remind me to look that up, guys. Hopefully I'll have that next class instead of me making up words. Which equation can be solved in one-to-one property? So if we want to solve this in one-to-one property, the only one that looks like it would be this one. The reason why I say that is, oops, I guess that wasn't it. Stop it. I'm not picking questions. Oh my gosh. So this one-to-one property, apparently what they're saying is, hey, if we just log both of them by the same thing, it's easier to solve. This one, I guess what we're doing is we're using the inverse property, so that's why that one doesn't count. This one, we're dividing by 4, and then we're using the inverse property. So this one-to-one property is this idea of logging both. In other words, what they're saying is, hey, who cares about this 4? Who cares about it? Just do x equals 7x plus 2. That's what they're saying right here. They're using the one-to-one property to be like, hey, we're doing the same thing. So if we're doing the same thing to both, why do we even care that this is a 4? I must have misunderstood what they meant by this one-to-one property. Yeah, so this one-to-one property means if we don't care about it, we're not doing it. So inverse is what I'm used to doing. This one-to-one property is they're saying like, who cares? Like this is A, this is A. Do we really need to write down log A M, log A, base A to the N? Do we really need to write that just to say M equals N? No. Do we really need to base both of these with the inverse property? No. It's basically doing the inverse property but saying, hey, we already know it's the same. Do we really want to do the inverse for it? All right. And so this one, like I said, they're both being done by the same base. They're both based by the same thing. I'll try to find a word for that later. So now we're going to talk about exponents. So these are properties of exponents. So this is kind of review. So I would write these down as notes. Go back to the slide 9, when you guys have time, and write this down. It does help out a lot. It's this idea of like, if you have a negative exponent, what happens? It goes to the bottom. What if you have the same base? So same base. Same base and adding. So the product with the same base. Well, we're going to add the exponents. Well, what are we going to do about the quotient with the same base? Oh, we're going to subtract the exponents, obviously. And the reason why this is negative is this idea of it's at the bottom, so we're subtracting. So I always thought that this rule should be taught before they talk about the negative exponents. Every textbook I've seen doesn't think of it that way, but I like thinking of it that way. If it's on the bottom, we're subtracting it. That's why it's negative. Power rule. So this idea that we have two different bases, two different factors. We have two factors here. We're just going to distribute this exponent to each factor. And the reason why they say b and a doesn't equal 0, because if this equals 0, then everything, if a equals 0, everything would be 0. If b equals 0, everything would be 0. It wouldn't affect anything. Here they're just saying a and b cannot equal 0, because what's the point of doing it? So in a quotient, we're still going to distribute this to each of the different, I don't know what the word is for quotient. I know in a product, they're called factors. When you're doing a quotient, I guess what we would call it would be, we'll distribute it to the product and we'll distribute it to the factor. I've never thought of that before. Because if we're talking about this, these are quotients, or these are factors, and this would be, I'm just making stuff up, and this would be our product. So that's why I'm saying it that way. So that's our product. This is our factor. Fractions, those are your roots. Powers, you just multiply the exponents. So this is a good slide to kind of review if you have trouble knowing the exponent rules. All right, so now the log properties. We've gone over these before. There's this idea that, think of it this way. If you rewrote this as an exponent, it would be the exponent rule. This idea that they cancel out, the inverse property, in other words. If you have b to what power gives you b, that's a 1. So these are good review slides. 9 and 10 are good review slides. I've already talked about these a lot in the other videos, so we'll just move on. But you guys can always review this if you need help understanding them. And if you need even more help, someone explaining these to you, let me know. We can set up an appointment. Or you guys can always go back to the videos where I covered these. All right, so now we're going to solve exponents, which I think isn't that bad, to be honest. We'll get into it a little bit. I'm going to skip these. You guys can review these on your own. What time is it? Okay, we're doing pretty good on time. All right, so let's get into this by solving it. So first, I'm going to rewrite this. So we have negative 2 ln quantity x plus 1 minus 3 is equivalent to 7. So what I'm going to do here is first I want to divide by this, or I'm getting ahead of myself, sorry guys. I want to add this 3. I want to get rid of this negative 3 right here. So I'm going to add to both sides. So bring everything down. Equals 10. All right, I'm going to start trying to color code stuff now too. Hopefully that will help you guys. Now we're going to deal with this negative 2. So what I'm going to do is I'm going to divide by negative 2. All right, So I'm going to bring everything else down that didn't cancel out, ln quantity x plus 1, and this is going to equal -5. So I can always show that I'm canceling this out. All right, and then I'm going to rewrite. So now I want to get rid of this ln. So what I'm going to do to get rid of this ln, I'm going to do e to both sides of this ln quantity x plus 1. All of this is equivalent to our -5, but since we're e'ing both sides, I'm going to e this side. I'm basing it by e. All right. And this will end up giving me x plus 1 equals, we're going to have to use our Google calculator. Let me bring this over here. I'm going to close the Dow Jones thing. We don't need this anymore. So calculator. I'm going to do E. There should be an E button here somewhere. There it is. E to the power of, what was it, -5 minus 5. I get this 0.00. I'm going to do 2 significant digits because these zeros are just placeholders. So I'm going to do 2 significant digits, so it's 0.0067, just to be a little more exact. So this is going to be equal to 0.0067. So once I subtract this, I'm going to subtract the 1, subtract the 1. I would end up getting x equals 0.993. Honestly, what I did was I knew it wasn't 5 because there was something here. I knew it wasn't 6 because that something was not a -5. I knew it wasn't this because this is what I got when I eat it. So I knew that. So that's how come I knew that answer. Does that kind of make sense how I did that? Yes, no, maybe. Are you guys awake? I know it's Monday morning. I'm sorry. All right, cool. All right, so next we're going to move on to this one. And this will be the last slide I do. It's a nice, easy day, especially since half of you guys aren't here. I don't want this video to be super long. So first things first, I want to somehow figure this out. What is going on here? Well, the first thing that I notice is I need to figure out how to make this into one ln. One ln. So I'm looking at this. I'm like, well, there's an ln here, an ln here, and this doesn't even have an ln. So first things first, I need to get rid of this -2. How am I going to get rid of that -2? Well, I'm going to use the power property. So I'm going to use this power property right here. So I'm going to use this power property. Click that. That's going to end up doing this. So what I did there is I'm like, okay, cool. I want to do the power property. Now I'm like, well, it looks like I'm subtracting here. So subtraction for ln. Subtraction for logs is the quotient rule. So again, if you guys forgot what that was, go back. So we're going to use the quotient rule or the quotient property here. So that's going to create this. It makes it one fraction. Now, let's see what they do. Oh, they call it the inverse property. I hate that they call it the inverse property. I'm like, I want to get rid of this ln. So I want to e both sides. I want to base it by e. How am I going to get rid of that? I'm going to get rid of this here by basing it by e. They say just use the inverse. So we're going to do the inverse. Cool. Now we have this. All right, from here, what I'm going to do is I'm going to, well, we can use the box method to try to figure this out. So we're dividing it by x squared. What are we dividing by x squared? This to x squared and the 4. Well, this is just a 1, and we're also going to divide this. So it looks like we're dividing it by x squared and multiplying it by 4. That's the only way to do this. If we do x squared times 4 divided by x squared, that's the only way I can think about solving this. So we end up getting this very weird answer. But let's see how they do it. So they say one-to-one property. That's not it. They're not both by an exponent. They're not both by a log. Take the natural log of both sides. Why? We just got rid of the natural log. So we're going to use algebra to solve for x. And they solve it by, I guess that makes more sense than what I was doing. Multiply it by x squared. I guess I just had a brain fart. I'm so sorry. They're like, multiply by x squared. Cool. Then we're going to subtract an x squared. Oh, that's way easier than what I was talking about. And then we do that. So that's half of the slide. So I'm going to assume that's like half of the work. We'll get into solving exponentials and logarithmic models in the next class. Other than that, I will see hopefully more of you on Wednesday. Let me close this out.